Good morning, good afternoon, and good evening, depending on where you're joining us from, and welcome to today's webinar. What you can't see is costing you millions, why automation starts with AI vision. My name is Casey Flanagan. I'm an associate editor of PMMI Media Group, and I will be moderating today's webinar. We have a great program planned for you, but before we dive in, here's something you don't want to miss, and that's PAC Expo International 2026, happening October 18th to the 21st in Chicago. This is the most comprehensive packaging and processing event in North America, bringing together 2,600 exhibitors with solutions for over 40 vertical industries. You'll see a lot of cross-industry technology and, of course, machinery up and running on the show floor. If you want to see what's new in the industry, connect with suppliers, hear from experts, and not only find solutions for your projects, but compare multiple options all in one place, you need to be there. Now is the time to register for the show, and as a webinar participant, you can register for free using the comp code WEBINAR. Visit pacexpointernational.com. Now, a few housekeeping items. On the right-hand side of your screen, you'll see the chat section. This is where you can share your thoughts and connect with other attendees throughout the session. Keep in mind that all comments shared here are public, so feel free to jump in now and let us know where you're joining from. We'll also be keeping an eye on the chat for questions for our speakers. You can post them at any time, and we'll answer as many as we can during the Q&A at the end. Any we don't get to will be passed along to the speakers for follow-up afterward. After today's event, you'll receive a follow-up email with a short survey. We'd love your feedback. You'll also get a link to watch the on-demand recording once it's available. If our speaker or sponsor have shared any extra materials, you can find them in the handout section located just below the video window. Now, on to today's webinar. This webinar explores why the highest return automation strategies start with visibility. By leveraging AI vision to understand products, processes, and production variability in real time, manufacturers can identify opportunities worth hundreds of thousands or even millions of dollars annually before making larger automation investments. And now it's my pleasure to introduce today's speaker, Noba Gurgis, Director of Business Development at Occipital AI. Noba helps manufacturers implement AI-powered vision solutions that improve inspection, quality, and automation across food processing, packaging, and industrial manufacturing. I know you'll enjoy today's presentation, and I'm excited to get things started. So with that, Noba, the floor is now yours.
Hi there, everyone. Thanks for taking the time and joining me today. I'm Noba Gurgis with Occipital AI, and I'm really looking forward to spending some time with you today. Every day on production lines around the world, millions of dollars quietly leak away. Not necessarily through dramatic breakdowns, but through things nobody can see. Today, I want to show you why the highest return automation strategies don't always start with buying a robot. They start with visibility. So today, there are really three things I'd like you all to leave with. Number one, where hidden costs hide. Number two, where AI vision comes first. And number three, how to de-risk automation strategies and implementations backed by real return on investment numbers at the end. So today's conversation, I'd like it to be more practical rather than theoretical. We're going to take the time to go through some details, understand the capabilities of Occipital AI's vision technology, and how it can be deployed in the real world. So our technologies, as you see here on the slide, can be deployed in essentially three manners: inspection on its own, inspection and machine control, or inspection and robotic guidance. See a pattern there? It all starts with inspection, right? So regardless of how you implement your vision solution, it does always need to start with the foundation of inspection. That foundation builds a validated foundation for an automation solution. Let's talk a little bit about how the technology actually works. So with Occipital AI's AI vision technology, we start out with 3D scans of your actual product. We then fuse the 3D and 2D data together. That fusion is actually what produces the accuracy and deep object understanding, right down to the ability to produce subpart classification and real dimensional data. The system doesn't just see an ear of corn. It sees kernels, it sees tip, it sees husks as part of the whole, and segments them accordingly so that you can classify those individual components and create reject references associated. From that scan data, the AI model actually generates its own annotations. You're getting perfect labeling that which requires no hand labeling, no human error. That's usually the most painful part in implementing a vision technology. It's the imaging, it's the labeling, it's the constant annotation. The synthetic image generation actually produces tens, if not hundreds of thousands of different variations of good products, bad products, different defect types, thousands of different environments, background scenes, and even lighting conditions. All of that done without any imaging or coding or annotation required. That's what those callouts really mean. Nobody on your team needs to take all that time and use up all that labor. You're getting deployment in days, not months. All those results, none of the hassle. So those are the inputs, right? Those inputs only matter if it produces something you can actually use on the plant floor, right? Here's what those inputs actually enable. Starting out with inspection and defect detection. You're getting the ability to find surface defects, presence and count, orientation, dimensional and geometric object identification. You're also getting the ability to detect foreign objects, right? And as we mentioned, classification and grading. Product inspection in real time at real speeds. You're getting all these defects and inspection qualities flagged. This isn't just one train trick. This is a full range of capability that a quality team actually cares about, all running at once. Getting to the machine control and robotics guidance side. This is where what the vision sees turns into actual action. Pass fail signals to your line, picking from chaotic piled product without the need to singulate. It also chooses the best item against your parameters, right? You can classify your reject reference based on your internal quality standards or the standards for your end user or client. It allows your robotic system, once you deploy robotics, to place the gripper correctly for every single pick, all while producing real-time analytics and traceability. It provides the live yield, throughput, and defect data by line, by shift. You can understand from a date range whether it was first shift, second shift, third shift, an hour ago, last week, last month, even last year. The key thing to remember here is that you're getting actionable insight, not just pass fail. Quantitative results with the easy pass fail indication. A traditional vision system is going to tell you that something failed or something went wrong on the line. This will tell you that your actual defect rate is climbing on a particular rate on a particular line at this very moment, while you can still fix it before it snowballs into a much greater problem. All three of these in one platform. You deploy it once and it grows into the rest that you need when you're ready. So let's take a look at some of the three things that I mentioned you'll get from today. We're going to start out with the hidden cost of automation. So the core problem is that many manufacturers are under constant pressure, right? Higher throughput demands, better quality, less labor dependency, and slim margins, right? For some, the immediate instinct is to upgrade processing equipment to solve it, or implement robotics immediately. That skips a step. First, it's important to gain a clear understanding of what's actually causing the waste and the issues on the line as it is before you just jump to upgrading your processing equipment. Looking at product giveaway and yield loss. too many pepperonis on a pizza, overfilled packages, trimming too much fat off a piece of pork loin or chicken breast. Seems like a minuscule amount per unit, but you and I both know that it adds up. Look, guys, these production lines in the real world, it's so challenging with today's capabilities to identify these individual small contributions to waste and loss. But the truth is, the technology actually exists right now, and it's not necessarily brand new. These are validated solutions that have been deployed in the real world. Occipital AI has been deploying these for solutions for years now, and we have real results to prove it. Looking at rework and foreign material risk, what's the cost of catching problems late, or worse, not catching them at all? Broken sticks, blue plastic in your products that are out to retailers and your end users, your clients, really anything other than what's intended in your food product, consider the food safety factor. You don't want these products to end up with broken sticks in them or anything that you don't originally intend to be in that product, right? Even looking at process inconsistencies, what's the impact related to variation of your products that you produce that make a difference in the long run? If you can't measure it, can you manage it? I personally don't think so. One killer stat, recovering as little as 1 gram of product per unit in the example of chicken or pork loins can translate into millions in annual savings. Let that sink in. Millions. Pause for a moment and think about that. And while you think about it, I'm going to give an example later on that shows you exactly how that 1 gram per product actually translates into millions. So be sure to keep questions ready. Early detection of process deviations prevents recalls, prevents downtime, and reduces wasted product before they snowball, before they turn into a significant loss or quality issue. So if it's that type of money and that type of safety risk on the table, the question becomes, what's the first move that actually captures it? And this is the question that most actually end up answering in the wrong order. So let's talk about it. Why does AI vision come first? So vision is actually the #1 failure point in robotics. Robotics rarely fail because of the robot itself. They actually fail because they can't see properly. Poor perception drives missed picks, reliabilities, and downtime. Maybe even a missed goal in the World Cup final. Who knows? These are the exact things that reduce return on investment or maybe completely eliminate it. Deploying AI vision first will actually surface those perception, inspection, and guidance challenges early on before you've committed all that capital to hardware associated with automation or a complete process upgrade. Ultimately, you're getting a real return on investment with or without robotics, right? AI vision is capable of performing high-speed inspection of highly variable objects in very messy, very unstructured environments, the actual real world. It's not necessarily a perfect environment or manufacturing space in most processing plants, right? You can't always have everything singulated. It can't always be perfectly presented, whether you're using a robot for pick and place, machine control, or even just doing inspection and have manual inspection on the line, right? It's really challenging to identify defects, identify what's good, what's bad, what's been trimmed too little, too much, or if you're topping a pizza with too many pieces of pepperoni or sausage. All of this information that's provided by these AI vision technologies actually feed a live dashboard. You're getting quality, throughput, cycle times, defect rates, and much more, all visible in real time. You can even drill down within the dashboard to pinpoint the exact product samples, defects associated, and reference the actual image that was captured for that particular product. That means you can optimize production right now. You don't necessarily have to wait for a full automation project to see the returns. Ultimately, the key point here is that vision isn't the thing that you add at the end of automation. It shouldn't be an afterthought. It's the actual foundation that you build everything else on, and it pays for itself on its own. So let's reinforce de-risking future automation just a little bit. Let's look at this system and how it grows with you. The same versatile AI vision platform that we're talking about today will actually handle quality inspection right now and machine control or full robotic guidance tomorrow, right? That's sort of the message we've been talking about. So essentially, an investment into vision inspection today becomes tomorrow's validated foundation for the automated solution without starting with rip and replace. You can capture real process data, defect rates, SKU mix, line speeds, and walk into conversations with integrators armed with evidence and data, which will end up accelerating the projects. You also aren't walking into a budget presentation meeting and upgrade proposal project with your VP of operations or chief revenue officer without the actual data, right? Decisions get made on operational data, lowering risk, shortening timelines, and prioritizing the highest impact opportunities first. Now, that all sounds fine and dandy, great in principle, right? Let's look at how that translates into real world actual scenarios. These are scenarios that we've deployed and have produced a real impact. So I'm going to walk through three different use cases that I hope resonate with you. And if these particular applications, if you don't find a correlation with your products, please reach out to us, let us know what your product is, and we can talk about it with your actual product. Correlate those real figures, those real values, those real reject rates with your actual product and determine a proper return on investment and understand your application, perhaps even with a proof of concept. Here's an example of an upstream prevention opportunity, starting out with egg rolls. Who doesn't love egg rolls, right? With an average defect rate of, let's say, 0.75%, we'll look at how prepared foods run on assembly economics, where a finished unit is built up from inputs of widely different values, and an egg roll production where the wrapper is nearly free. Look, every penny counts, right? But about 2 cents per wrapper. And the filling is 37 times more expensive at 75 cents per unit. Every single piece that comes off the line carries both the wrapper and the filling, but only one of them actually matters financially, at least when you're talking about waste. That asymmetry is the whole opportunity, and most plants don't really take a deep dive into it. They don't look at it as deeply as they should because a defect is a defect regardless of when it happens, right? Wrong. The problem is that the wrapper defects are decided early and paid for late. A wrapper can be misplaced in the fixture, torn, folded, or damaged before anything is dispensed into it, before that filling is actually placed onto the wrapper. At that moment, the plant has lost 2 cents, right? But the line doesn't necessarily know that the wrapper's bad, so the filling head dispenses 75 cents of product onto it anyway. And now the plant has lost 77 cents. The wrapper defect was cheap, but committing the filling to it is what made it expensive. Our AI vision system in this scenario inspects the wrapper before the filling is dispensed. It verifies the placement relative to the fixture, checks for damage, any tearing, full defects in real time at full line speed. When a wrapper fails inspection, the system signals to the line to divert it before the filling head ever fires. That unit of the wrapper is rejected while it still costs just 2 cents instead of 77 cents. The key point here is where intervention happens. It's not at the end of the line inspection catching a bad product after money's already wasted, after it's already spent. It's upstream detection that projects that have the highest value input on the line before it's committed to the filling and isn't sellable. The further upstream you prevent a defect, the less it costs you. And the wrapper stage is as far upstream as this process gets. Now, the commercial impact here really scales with volume. I know you see a big number on the screen here. Let's talk about how you actually achieve that. At 1,000 pieces per minute, 16 hours a day, 260 days a year across 5 lines, even at this 0.75% scrap rate, adds up around the clock. That scrap rate represents more than $6 million in losses annually against less than 200,000 in wrapper scrap. By catching that defective wrapper first and preventing that filling loss from actually happening, you're getting that 2 cent per wrapper discarded. That nets out to more than 6 million, almost 7 million per year in recovered value. Now, the actual operational outcome here, the broader operational outcome, is that the plant stops paying for its most inspective input twice. You're getting less waste, better material utilization, and cleaner downstream quality with a repeatable model that applies where a low value carrier meets a high value fill. Find the moment where the cheap thing commits, the expensive thing, and inspect there. Let's take a look at another example. Sweet corn. How do defects actually turn into lost sales? Let's look at how real-time inspection prevents unsellable products from reaching store shelves with sweet corn. Missing kernels on corn are easy to overlook operationally, but they really do create a major commercial problem because consumers make buying decisions visually. Even small visible defects, especially at the tip of the ear, can make an entire package look low quality. As a potential customer, if I'm going to a store, I'm buying a pack of corn for a barbecue with my family. I bring it home. The family sees, tip fill defects or some aborted kernels. Yeah, it's a shame. We're missing a piece of corn. Now everyone in the family doesn't get their piece. Someone's definitely going to be upset. I can tell you for sure, my nieces will fight for the best ear of corn, no question. And if one of them gets a bad ear, no one gets a piece of corn. Now, in a retail environment, one bad ear doesn't just affect that single piece. It's going to cause not just me as a consumer to reject the entire pack or just make my nieces upset. It could cause the retailer that you're selling to reject the entire pack and get reduced brand recognition, which means the value of all the good corn in that package is lost with that one defective cob. Now, in this example, each unsold package represents about $7 in lost sales. Now, that volume makes this issue financially meaningful. If you're looking at 1 million pieces of corn processed per day with a defect rate at about 0.33%, you're looking at around 3,300 defective pieces per day entering the line if that defective piece isn't removed. If those defective pieces of corn make it into the final package, that results in 23,000 lost sales per day and about 115,000 in lost revenue per week. Now, we'll address these issues by implementing our AI vision inspection system before the final packaging stage, where every single ear of corn is scanned for defects before they're fully packaged, and even after if you'd like. Now, these defective pieces are identified and removed in real time before they ever reach the final consumer or even the retailer in those packages. This improves the package quality consistency, protects shelf life appeal, and maintains stronger sell through rates and brand recognition. It also prevents just one defective corn piece to cause the entire loss of multiple otherwise sellable ears in the same pack. The process is automated in the end, but it doesn't slow production, making it operationally practical as well as a savings in not just money, but also waste. Let's take a look at another example. Chicken breast, right? Poultry processors are paid by the pound, which means one small change in retained product weight can create a direct revenue impact. In this case, the challenge is not simply removing fat or trimming fat, it's trimming each chicken breast to the correct level. If too much is removed, processors lose sellable yield and give up the profit. If too little is removed, the product may fall outside the supermarket specifications, which can lead to lower payouts, rejection, rework, and operational inefficiencies. In this scenario, our AI-driven inspection system can classify and sort chicken breasts by trim level in real time. The system is actually able to identify whether the trimming machine is removing too much or too little fat, giving operators immediate visibility into the process performance while production is still running. The key value here is that the system is more than just a detection tool. It's sending real-time alerts so that plant managers and operators can adjust the trimming process immediately. That means that the plant can prevent ongoing giveaway and reduce off-spec product instead of discovering problems later after yield has already been lost. The commercial impact here is also significant, just like the others. At a typical plant, the system performs more than 27 million inspections per year. Saving just 1 gram per chicken breast across 6 processing lines can generate more than $1.6 million in annual recovered revenue. Even if very small per unit improvement scales into meaningful financial return, that makes sense at plant volumes. You end up getting improved compliance with supermarket specifications and regulations, of course, less waste, smoother production through faster intervention, and better support for your continuous improvement processes on the plant floor. Guys, that's not just optimizing, it's a complete shift in efficiency and profitability. So let's bring this all full circle. At the start of this session, I promised you'd leave with three things, right? Let's close the loop on each one of those. Starting out where hidden costs hide. Where do these hidden costs hide? In plain sight. Giveaway, rework, and process inconsistencies are on your line right now as we speak. They're invisible because they're small, but just because you can't measure them at the moment doesn't mean you can't in the future. We saw what happens when you can actually measure them, right? The egg roll, the corn, the chicken, all those numbers were sitting there just waiting to be found. Now let's recap on why does AI vision come first? Can anyone guess? I hope so. It's the foundation. Vision's the number one failure point in robotics. So deploying it first actually surfaces those hard to find problems before the capital for fully automated deployments actually is committed. And it pays for itself before a robot even arrives, just through inspection alone. And last but not least, how do you de-risk automation all while still achieving a return on investment? Guys, don't guess. Automate based on real data. Today's inspection system becomes tomorrow's foundation for a validated automation solution. You walk into automation decisions with throughput data, defect data, SKU data, all this information at your fingertips instead of assumptions or guesses, even if they're educated guesses. Every single case we showed today was proven in the real world. We can prove that with your actual product as well. The value was always there for your actual products, for these client use cases. On every one of those lines, the money was already leaking, the waste was already apparent before anyone even thought of a new automated solution, implementing upgraded OEM processes. Vision is just simply what allows you to see the challenges and act on it, with or without the full automation. So ultimately, guys, if you take one action after this webinar, make it a look on your own line. Analyze the process, or better yet, consider it, bring it to us, and let us evaluate it for you. Show us some examples. We'll come out to your manufacturing line and run some real return on investment figures with you. Even run a real proof of concept with your actual application. We can take those 3D scans on your product and run a proof of concept so that you can see it and build a confidence even before you commit to implementing an AI vision solutions. Let us show you what the first steps look like without the risk associated. So with that, I'd like to thank you guys. Thank you all for taking the time to join me today and learn more about how Occipital AI's vision solutions can really save you millions in the long run, reduce risk, and provide a very quick and impactful return on your investment. I welcome you all to a brief Q&A session. I'm really looking forward to this session. More than welcome to introduce any of the questions you guys may have. And if we don't have enough time to get to all your questions, please still send them our way. We'd love to reach back out via email or phone call, whatever it might be. And we're very much looking forward to interacting with you guys further. Last but not least, don't forget, as mentioned earlier in the conversation, we would love to see you all at PEC Expo. We'll be there and hope to see you there. Thank you all for your time.
All right. Thank you very much for that presentation, Noba. That was excellent. At this point, we'll proceed over to the Q&A portion of the program. So those of you in the audience, if you haven't already, please enter your questions into the chat to the right. We've received a lot of great questions already, so I'll just dive right in. The first one I see here is, what is the difference between traditional machine vision and AI vision?
That's a really good question. I'm glad you asked. Traditional vision versus Occipital's AI vision. So look, there are quite a few differences, and tell you the truth, there's a lot of scenarios where traditional vision fits and scenarios where AI vision fits. If it's a standard run-of-the-mill application that has pretty good consistency and no organic variability, traditional vision might be your best bet. But the moment you introduce variability, that's where AI vision comes into play, right? No one piece of corn, pepper, chicken, egg roll is the same. You can't create a CAD file for a chicken breast and expect it to be the same with thousands of different samples going through the production line. You also can't just take one image and expect that to really show the differentiation between product variation throughout your real world production environment. The main difference between traditional vision and AI vision is that synthetic image generation and data generation, right? So with traditional vision, you need to take hundreds, thousands, if not tens of thousands of different images of variations of good products, variations of bad products, and the different defect types with environment, scene backgrounds, lighting changes. Annotate them, label them. It's extremely cumbersome and labor intensive, which turns out to be costly. With Occipital's AI vision technology, you're eliminating the need for all of that. You take just a handful of 3D scans. We'll end up fusing that 3D and 2D data together to generate all those variations synthetically and then validate them against a real world product as we deploy. So long story short, traditional vision is labor intensive and doesn't account for product variability, which is every product in the food industry, let's be real, while AI vision does all the work for you.
Great. All right, that makes sense. That variability is the key there, and very interesting what occipital AI is able to do in kind of speeding that process up. Great. Another one here. Do I need AI or coding expertise to use the V Cortex?
Another good one. So, for those that don't know, vCortex is effectively the platform that powers this system and the cloud analytics dashboard as well. So, the answer is no. You don't need AI or coding expertise. vCortex was actually designed for accessibility and some serious ease of use. If anyone's familiar with manufacturing operations or just how to press a button effectively, you can set up new workflows starting with pre-trained AI vision models. You're not going to need to program these models or reject references or recipes on your own. We're here to help, and we'll end up providing these pre-trained AI vision models for you. Of course, taking into account your quality standards, needs, or reject references associated. These all can be tuned, and it's really, really quite easy to adjust them even on the fly if needed.
Great. All right. And then, in a similar vein, it seems another question here is: can V Cortex be integrated with my existing systems?
Yeah, so the entire platform. So vCortex paired with the actual hardware associated. So whether it's the our VX2, OX2, or TX2 platform, which is the actual system, the hardware itself, can absolutely be integrated. You can integrate them with existing PLCs, robots, or really any automation system using standard industrial protocols. Even optional APIs are available within our recipe builders for publishing data to SCADA or WES solutions.
Fantastic. Okay. Another question here: how does V Cortex handle different environments and product variations?
That's a great question, and it sort of alludes to the difference between traditional machine vision and AI vision, or at least my answer to that. So, our AI vision models are pre-trained to be robust enough to account for this environmental variability, even if it's lighting changes, reflections, cluttered backgrounds, or, for example, a discoloration on the conveyor due to raw poultry being processed throughout a shift, right? It might not necessarily be a dramatic change, but it can make a difference. They can also be fine-tuned to those specific products or processes if needed. I'll be honest with you guys. I know you can see a lot with the human eye, myself, and I know many others out there. I'm partially colorblind. Those little changes might make a difference in the long run. I wouldn't be able to see a lot of those myself. This system, you're taking out all that subjectivity. This is producing quantitative data based on actual results that don't rely on variability. Doesn't matter what happens in the environment. This system is trained on a 3D photorealistic version of your product and tens, if not hundreds of thousands of variations in data that the model can accommodate for it.
Fantastic. That does sound very reliable. All right. One more here. How does the solution's ROI go beyond inspection?
That's also a very good question. So this sort of ties back to some of those examples I gave earlier on ROI, whether you're looking at the egg rolls, the corn, or the chicken. But ultimately, in my opinion, I think one of the most valuable components of this is related to the analytics dashboard. The level of data you actually end up with, just even with inspection, before you actually implement that machine vision or robotic guidance, even if you just have one of our camera systems on your conveyor scanning the products as they pass through, you end up getting the data behind your throughput rates, your yield, your typical reject rates per shift, you can start to identify if you encounter more defects on a particular shift. Look, it's usually we'll say in third shift, but it could even be during a shift change if you have consistencies on each shift during a shift change or after a weekend during the initial startup, and start to identify the root causes associated to those inconsistencies and reduced yield or increased rejects, right? So ultimately, the ROI goes beyond inspection by obtaining the data and utilizing that data to improve the process or prevent the same issues from occurring over and over and over again, all while providing that foundation that you're going to use in the long run anyway when you deploy automation. I hope that answered that question.
Absolutely. Yeah. Thanks for explaining. That makes sense. So that's all for now. So again, thank you, Nova. And thank you to our sponsors at Occipital AI. But mostly thanks to all of you in the audience for your participation today. For those of you who have asked, you'll be receiving a follow-up email with a link to watch the on-demand recording. Included will also be a link to our feedback survey. We'd appreciate if you just took a couple minutes to share with us what you thought about today's program. Thanks once more to our attendees around the world. We invite you to join us again on Thursday, August 6th at 1 p.m. Eastern, 10 a.m. Pacific for our next webinar, Hygienic and FDA-grade air-operated double diaphragm pumps for food applications. Finally, before we wrap up, just a quick reminder about Pack Expo International 2026 coming up October 18th to the 21st in Chicago. This show is your chance to see the widest range of packaging and processing solutions anywhere and to connect with experts who can help you to find solutions. Whether you're focused on automation, sustainability, food safety, digitalization, or something else, with 2,600 exhibitors on the show floor, you can't go wrong. Make sure to register and don't forget that you can do so for free with the comp code webinar. Visit packexpointernational.com for all the details. Have a great day.